Time travel. It's the stuff of dreams, of science fiction. Who hasn't wished to witness the dinosaurs, to meet their heroes, or to glimpse their own future? From H.G. Wells' Time Machine to the DeLorean speeding through Back to the Future, time travel has captivated our imaginations for over a century. But is it merely a fantasy, or could it one day be a reality? Science is beginning to unravel the mysteries of time, revealing a universe stranger and more wondrous than we ever imagined. For centuries, time was considered absolute, unchanging, a river flowing in one direction. But in the early 20th century, Albert Einstein shattered this notion with his theory of relativity. Time, he revealed, was not a river but a dance, a dimension woven into the fabric of space-time. And like any fabric, space-time could be bent, warped, perhaps even torn. This revelation opened up a Pandora's box of possibilities, including the tantalizing prospect of time travel. Could we, by manipulating the fabric of space-time, journey through time as we journey through space? The answer, like the universe itself, is full of mystery and possibility. Imagine folding a piece of paper in half. Now imagine a tiny worm burrowing a hole through the folded paper, creating a shortcut between two distant points. That, in essence, is the concept of a wormhole, a theoretical tunnel through space-time connecting two different points in the universe, perhaps even different points in time. While still purely theoretical, wormholes are permitted by Einstein's equations of general relativity. These equations describe gravity not as a force, but as a curvature of space-time caused by mass and energy. Just as a bowling ball creates a dip in a stretched rubber sheet, massive objects warp the fabric of space-time around them. If space-time can be warped, could it be warped enough to create a shortcut, a wormhole? If so, stepping through such a portal could transport us vast distances across the universe, or even backward or forward in time. However, creating and stabilizing a wormhole would require unimaginable amounts of energy, far beyond our current technological capabilities. One of the strangest predictions of Einstein's relativity is time dilation. It states that time is not absolute, but is relative to the observer's motion. The faster you travel through space, the slower time passes for you relative to someone who is stationary. Imagine two identical clocks, one on Earth and one on a spaceship traveling at a significant fraction of the speed of light. As the spaceship speeds away, time on the spaceship would appear to slow down from the perspective of an observer on Earth. The astronaut on the spaceship, however, would experience time normally. This phenomenon, known as time dilation, has been experimentally verified using atomic clocks. While the time differences observed at everyday speeds are minuscule, they become increasingly significant as we approach the speed of light. This suggests that time travel into the future is theoretically possible, though it would require technology far beyond our current grasp. Time travel to the past raises a host of mind-bending paradoxes, the most famous being the grandfather paradox. Imagine you travel back in time and, for whatever reason, prevent your grandparents from ever meeting. This would mean you would never have been born. But if you were never born, how could you have traveled back in time to prevent your own birth in the first place? This paradox highlights the potential contradictions inherent in time travel to the past. It suggests that altering the past, even in the slightest way, could create ripples through time, leading to unforeseen and potentially catastrophic consequences. Some physicists believe that such paradoxes might be prevented by a hypothetical mechanism known as the Novikov Self-Consistency Principle. This principle proposes that if time travel is possible, the laws of physics would conspire to prevent any action that would create a paradox. Section 5. The Bootstrap Paradox. Where did it all begin? Another intriguing time travel paradox is the bootstrap paradox. Imagine you find a beautiful piece of music but can't find its composer. Years later, you travel back in time and, in a moment of inspiration, transcribe the music and present it as your own. The music becomes a timeless classic, eventually inspiring you to travel back in time and transcribe it, completing the loop. But where did the music originate? The bootstrap paradox illustrates how information or objects could become trapped in a closed loop. existing without a clear origin. It challenges our understanding of cause and effect, suggesting that in a universe with time travel, the origin of things might not always be clear or even definable. Section 6. Cosmic Architects, Einstein, Hawking, and Thorne. The quest to understand time travel has been driven by some of the most brilliant minds in history. Albert Einstein, with his theories of special and general relativity, revolutionized our understanding of time and space, laying the groundwork for all modern discussions of time travel. Stephen Hawking, a giant in the field of cosmology, explored the nature of black holes, those enigmatic objects whose gravitational pull is so strong that not even light can escape. His work further blurred the lines between science fiction and reality, suggesting that black holes might hold the key to unlocking the secrets of time travel. Kip Thorne, a renowned theoretical physicist, has made significant contributions to our understanding of wormholes and the possibility of using them for time travel. His work has inspired generations of scientists and science fiction writers alike, pushing the boundaries of what we believe is possible. Section 7. Time Travel Today. Experiments and Explorations. While we may not have DeLoreans or time-turning devices yet, scientists are actively exploring the boundaries of time. Experiments with atomic clocks have confirmed time dilation, demonstrating that time is indeed relative to motion. Researchers are also investigating the quantum world, hoping to uncover the secrets of time at the smallest scales. One particularly intriguing area of research is quantum entanglement, a phenomenon where two particles become linked, even when separated by vast distances. Changes to one particle instantaneously affect the other, regardless of the distance between them. Could this bizarre connection, which Einstein famously called spooky action at a distance, hold the key to manipulating time? While we are still a long way from building a time machine, the pursuit of this scientific holy grail continues to inspire groundbreaking research and expand our understanding of the universe. Section 8. The Ethics of Time Travel. A glimpse into the future. The possibility of time travel raises profound ethical questions. If we could travel to the past, would we have the right to alter history? Could we resist the temptation to change the course of events, even if it meant potentially unraveling the fabric of our existence? And what about the future? If time travel becomes commonplace, what impact would it have on our present? Would the knowledge of future events paralyze us with predestination, or would it empower us to create a better tomorrow? These are not merely philosophical musings, but pressing questions that we must grapple with as we venture further into the unknown. The ethics of time travel are complex and multifaceted, demanding careful consideration and responsible exploration. Section 9. Possibilities and Impossibilities. What the future holds. So, is time travel truly possible? The honest answer is, we don't know for sure. The laws of physics, as we currently understand them, allow for the possibility of time travel, but the technological hurdles remain immense. Creating wormholes, traveling at near-light speeds, and navigating the paradoxes of time travel are challenges that may take centuries, if not millennia, to overcome. However, the history of science is filled with examples of seemingly impossible dreams becoming reality. From the first powered flight to landing on the moon, humanity has repeatedly defied expectations and pushed the boundaries of what's possible. The quest to understand time travel is ultimately a quest to understand the universe and our place within it. And in that quest, we may discover technologies and possibilities beyond our wildest imaginations. Section 10. Keep looking up. The universe of endless wonders. Even if time travel remains elusive, the very act of contemplating it enriches our understanding of the universe and our place in it. It reminds us that the universe is far stranger and more wondrous than we can imagine, full of mysteries waiting to be unraveled. So the next time you gaze up at the night sky, remember that you are looking at a tapestry of time and space, a canvas upon which the grand story of the universe is written. Who knows what secrets it holds, what wonders await us in the vast expanse of the cosmos? Keep looking up, keep questioning, and keep exploring. The universe is full of possibilities, and the future, like the universe itself, is full of endless wonder.